Welcome back. I'm Wolfgang Bock from Germany and I explain Sekus theory, part 7, nuclear disintegration. What is nuclear disintegration? Some elements, like urine, disintegrate over time. And why did they? And what happened? And what is radioactive? What are X-rays? I show you. When an atom is destabilized by too many neutrons, it happens that it disintegrates. If this is an atom, the urine, then it disintegrates to a smaller part of urine and something very small. But what happened? This kind of atom is bonded into a stabilized, it's integrated into other same-sized atoms. It's stable. If it now disintegrated to two different parts, or more than two possibly, then this is smaller than this, even if it's urine. So there's only a minor difference in size, causing a little frequency. Like in Sekus theory, waves, different sizes means different in frequency or difference in energy. Difference in energy causes waves. So this to this generates possibly infrared. It felt warm. Every radioactive thing feels warm. That is the small difference in size. But it loses something. It can be one or more parts. Possibly single quants are. It disintegrates to single quants some. And if you have a single quant, which is the smallest part possible, neighboring one of the largest atoms possible, then it generates very high frequency waves. And this is what radioactivity is. So, but what happens to radioactivity? Because the quant owns a negative potential, it hooks itself to the most magnetic thing or the most positive electric field neighboring. And that is why it keeps being. The quant, a single quant in an atomic world causes radioactivity, because every atom is that bigger than the single quant, because the quant comes from an atom, so it's a possible 1 to 500, 1 to 1000 in size, and this is immense. Yeah, that is what radiation is. And what can we do? If I'm right, the quantum with a negative load is affected by electric fields, possibly. So if you want to clear radioactivity, you have to move the particles which are not radioactive on their own, which only had catched some quants, through an electric field, so the quants possibly moves to the positive side, and the things that are not radioactive on their own getting cleared. And if the quant exists long enough, possibly, because of its small size, it have to go away. Like the spinning quantum rule says, the small parts cannot exist here on its own, so it's moved to space, if possible. If not, it stays here. And yeah, I hope you enjoyed. This was a short part. Next part is about the start and the end of the universe. Be happy, keep watching, keep thinking. Till tomorrow.